Two galaxies, each containing hundreds of billions of stars, are hurtling toward each other at 250,000 miles per hour, and not a single star will physically touch another. That's not a paradox. That's the most mind-bending truth in all of astrophysics, and it's just the beginning. Fact number 1. Stars almost never collide during a galaxy merger, even when two galaxies smash together at full speed. Here's the thing that breaks people's brains. When two galaxies collide, and we're talking about structures containing anywhere from 100 billion to over a trillion stars each, the actual probability of any two individual stars making direct contact is almost exactly zero. Why? Because space inside a galaxy is almost incomprehensibly empty. The average distance between stars in a galaxy like the Milky Way is about 4 to 5 light-years. A light-year is roughly 5.88 trillion miles. To put that in perspective, if the Sun were the size of a grain of sand, the nearest star, Proxima Centauri, would still be about 4 miles away. So when two galaxies merge, it's less like two armies clashing sword to sword and more like two enormous swarms of fireflies drifting through each other in the dark. The stars just pass. The galaxies themselves are transformed completely, but the individual stars sail through largely unscathed. Visual note: show an infographic of star spacing, a to-scale dot diagram demonstrating the vast emptiness between stars within a galaxy cross-section. Fact number 2. The Milky Way is already on a confirmed collision course, and the countdown clock reads 4.5 billion years. This isn't a theory. This isn't speculation. In 2012, NASA used the Hubble Space Telescope to make precise measurements of the motion of the Andromeda Galaxy, also called M31, and confirmed beyond scientific doubt that Andromeda is heading directly toward the Milky Way at approximately 250,000 miles per hour, or roughly 110 kilometers per second. The collision is expected to begin in about 4.5 billion years, with the two galaxies taking another 2 billion years after first contact to fully merge into a single, new elliptical galaxy. Astronomers have even given this future galaxy a name, Milkomeda, or sometimes Milkdromeda. Our Sun will almost certainly survive the merger intact, though it will likely be flung into a completely different region of the new combined galaxy. Visual note: display a timeline infographic showing the staged merger of Milky Way and Andromeda across billions of years, with color-coded phases. Fact number 3. Galaxy collisions trigger violent starbirth explosions that create millions of new stars in just a few million years. When two galaxies collide, the stars largely pass each other by, but the gas clouds between those stars absolutely do not. Unlike stars, these interstellar gas clouds are large, diffuse, and spread out across enormous regions. When two galaxies interpenetrate, these gas clouds slam into each other at tremendous speeds, creating shockwaves that compress the gas so intensely that it triggers runaway gravitational collapse. The result is what astronomers call a starburst, a period of star formation so explosive and rapid it's almost violent in its productivity. The galaxy known as ARP 220, located about 250 million light-years from Earth, is a classic example. It's the product of two spiral galaxies that merged roughly 700 million years ago. Today, it's forming new stars at a rate approximately 300 times faster than our own Milky Way. In cosmic terms, it's a factory running at full overcapacity. Visual note: display a comparative bar chart showing star formation rates, Milky Way versus ARP 220 and other starburst galaxies, using color-coded bars. Fact number 4. When two galaxies merge, their supermassive black holes begin a death spiral that releases more energy than billions of supernovae. Every large galaxy in the known universe contains a supermassive black hole at its center. The Milky Way's central black hole, Sagittarius A*, has a mass of about 4 million times the mass of our Sun. Andromeda's central black hole is even more massive, estimated at roughly 100 million solar masses. When the Milky Way and Andromeda merge, these two black holes will not simply sit still. They will be drawn toward each other by gravity, sinking to the center of the new combined galaxy over hundreds of millions of years. As they spiral closer, they will begin orbiting each other, creating a binary supermassive black hole system. This spiral will radiate enormous amounts of energy in the form of gravitational waves, ripples in the fabric of spacetime itself, and when they finally merge, The single burst of gravitational wave energy released will exceed the total light output of billions of stars simultaneously. In 2023, the North American Nanohertz Observatory for Gravitational Waves, NanoGRAV, detected what appears to be a background hum of gravitational waves consistent with thousands of supermassive black hole pairs in the process of merging throughout the universe right now. Visual note: show an orbital diagram of a binary black hole system with an animated spiral path and a gravitational wave ripple chart. Fact number 5. Galaxy collisions can completely erase a galaxy's spiral structure, turning it into a completely different shape of galaxy. When you look at photographs of galaxies, you'll notice they come in distinct shapes. Spiral galaxies, like the Milky Way or Andromeda, have those beautiful sweeping arms. Elliptical galaxies are smooth, featureless, egg-shaped or spherical blobs of stars. For most of the 20th century, astronomers weren't entirely sure why elliptical galaxies existed. The answer turned out to be galaxy mergers. When two spiral galaxies collide and merge, the complex ordered rotation of their spiral arms is scrambled. The stars that once moved in organized circular orbits get thrown into chaotic, randomized trajectories. Over billions of years, this randomization smooths out into the featureless elliptical shape we observe. Computer simulations run by researchers at Harvard's Center for Astrophysics, published in 2006 and refined repeatedly since, confirmed that major mergers between similarly sized spiral galaxies consistently produce elliptical galaxies. The Milky Way-Andromeda merger is expected to produce exactly this result, transforming two spectacular spiral galaxies into a single large elliptical. Visual note: show a before and after comparison infographic, two labeled spiral galaxy diagrams transforming via merger steps into a final elliptical galaxy shape. Fact number 6. Some galaxies are so powerful they literally eat other galaxies, and the Milky Way has already done this at least 15 times. Not all galaxy mergers are between equals. Sometimes a massive galaxy simply cannibalizes a smaller one, absorbing its stars entirely. This process is called galactic cannibalism, and it is extremely well documented. In 2018, a team of astronomers analyzing data from the Gaia Space Telescope, which has been mapping the positions and movements of over 1 billion stars in the Milky Way with extraordinary precision, discovered strong evidence that our galaxy consumed a large dwarf galaxy approximately 8 to 11 billion years ago. They named this ancient victim Gaia Enceladus, and its absorbed stars make up a significant portion of what we call the stellar halo of the Milky Way. Further analysis has identified at least 15 separate merger events throughout the Milky Way's history. Right now, the Milky Way is in the process of absorbing the Sagittarius dwarf galaxy, a small satellite galaxy that has already passed through the Milky Way's disk multiple times and is being gradually torn apart and consumed. Visual note: display an infographic timeline of known Milky Way merger events, using labeled color-coded markers on a cosmic age scale. Fact number 7. A galaxy collision once created a ring of fire, a galaxy shaped like a perfect cosmic bullseye 150,000 light-years across. Most galaxy mergers produce irregular, messy shapes or elliptical galaxies, but under exactly the right conditions, a head-on collision between a smaller galaxy and a larger one can produce one of the most spectacular structures in the universe, a ring galaxy. The most famous example is the Cartwheel Galaxy, located approximately 500 million light-years away in the constellation Sculptor. About 200 to 300 million years ago, a smaller galaxy punched directly through the center of what was then a normal spiral galaxy at high velocity. The gravitational shockwave from this impact radiated outward like ripples from a stone dropped in water, sweeping up gas and triggering an intense ring of star formation approximately 150,000 light-years in diameter. NASA's James Webb Space Telescope captured extraordinarily detailed images of the Cartwheel Galaxy in August 2022, revealing new details about its ongoing star formation activity and the distorted inner structures caused by the ancient collision. Visual note: show a color-coded JWST image diagram of the Cartwheel Galaxy with labeled structural zones, inner ring, spokes, outer ring, as an annotated infographic overlay. Fact number 8. Scientists have calculated that if you were standing on a planet during a galaxy merger, the night sky would gradually transform over millions of years into something almost unrecognizable and breathtakingly beautiful. This is the one that truly puts the scale of galaxy collisions into human perspective. Right now, from Earth, we can see the Andromeda Galaxy is a faint smudge in the night sky in the constellation Andromeda, roughly the apparent size of 6 full moons, but too dim to see without dark skies. As Andromeda approaches over the next 4.5 billion years, it will grow larger and larger in our sky. About 3.75 billion years from now, Andromeda will begin to visibly distort, its shape warping as gravitational tidal forces start reshaping both galaxies. At the moment of closest approach, roughly 4.5 billion years from now, Andromeda will sprawl across a significant portion of the entire visible sky, a vast, luminous, multi-armed structure far brighter than anything in our current night sky. As the two galaxies begin to merge and new star formation explosions ignite across both galaxies, the sky will be filled with intense new star clusters and nebulae glowing in colors our current sky cannot show. Astronomers at Johns Hopkins University produced detailed simulations of this progression, released publicly in 2012 and updated since, showing frame by frame what humans, or any beings on Earth, would theoretically witness across this multi-billion-year transformation. The final merged galaxy, Milky, will glow in the sky as a brilliant elliptical structure. No spiral arms. Just pure, dense, ancient starlight. Visual note: show a sequential infographic panel, 6 labeled skyview diagrams illustrating the changing appearance of Andromeda from today through the full merger, using simulated starfield color illustrations. 2 galaxies. Trillions of stars. Billions of years. Almost zero direct collisions between individual stars, and yet the result is a completely transformed universe, with new stars born, old structures erased, black holes merging, and skies rewritten from scratch. The cosmos doesn't destroy things when it collides them. It remakes them entirely. Subscribe to Moonlit Minds for daily mind-blowing facts that will change how you see the world.